Okay, this is force sensing on hobby servos, take 96. So, what we have here is how to take a hobby servo and be able to measure the amount of output load or force on the horn of it. What we have here is a potentiometer controlling a servo signal pulse generator to a little bit of circuitry to a servo, and the circuitry is monitoring the current pulse on the motor as opposed to the idle current that the servo normally draws. And I have the oscilloscope going here, and it has the tap from the detector, the current detector for the motor, that it's watching. So I will demonstrate here first. Sorry for the messy desk, and if I move the servo back and forth here, you can see kind of, maybe if I turn, is that any better? No, I'd have to turn the shop lights off. Brightness up? Okay, well, whatever. You can kind of see the trace there. Scope. If I move the servo a little bit, you can see that the scope gets a little bit of a pulse with the power going into the motor. This is no load, so this is the pulse generated for the motor just in the idle bumping of the gears back and forth in its servo action. So now what I can do here, I'm going to get this all out of order. Oh, look at that, knocked the scope off. Oh yeah, one-handed. Isn't it great? I should have a robot holding the camera for me. Just a sec, I'm just trying to hook the scope back on with no eyes here. There we go. Okay, so here's servo, done. Now, if I load the servo up a bit, you can see that what it's doing is the circuitry internally is trying to correct the position back from me pushing on it. So it's pulsing the motor. And the harder I push, I don't know how well this is coming out, but the harder I push, you can see that, I can make it so you can see the servo too. The harder I push, you can see that the longer a pulse the circuit applies to the motor, try and correct the position of the servo. And this is just an SG90, so good old Chinese Tower Pro. Now, the circuit that I have doing it, so basically what we're getting here is the length of the pulse is proportionate to the amount of force on the horn of the servo. And that pulse could be measured with an AVR or a Pi or what, propeller, whatever the heck is going around now. So this is my circuit, and what I've got here is, I'll explain it first and then I'll actually draw it so that it makes some sense. I got my power rails down here, and the control unit has its power going into it. The control signal for the servo is going directly into the servo. I've got ground. Where's my finger? Here's something to point with. I got the ground wire for the servo directly goes into the ground, but the positive for the servo, which is right here, goes through the base emitter junction of a PNP transistor. The collector of that transistor has a pull-down resistor, and that collector is what I've got the scope going to right now. So come on, give it some focus. There we go. The base emitter is shunted with, I just got here a 47 ohm resistor, and that helps separate out the idle current of the servo versus the actual motor drive current that's going on. So here, let's draw it. So what we got is positive rail, negative rail. I've got my, I know what the problem is here, I'm not left-handed. There we go. So we've got the control pulse generator, it's getting its power directly off the rails. This is very interesting to do with the camera lag. So, and it's got its potentiometer here that I'm controlling. This has got a tiny 13 in it. Code's available if anybody wants it, but nobody ever listens to me, so it's not. So this is a control pulse for the servo, and the servo, I'm just going to do the servo as another box here, has its signal, and positive and negative. And yeah, this is interesting with the lag. Okay, so negative I have going directly to the negative rail of my power supply. This is negative, and this is positive. And what we have up here is a PNP transistor, and I've done this in an interesting way. The transistor sits with the collector on positive rail and the base on the servo. And the reason I'm doing this is because I'm wanting to detect current, and bipolar transistors are current devices that are really good. Oh, the lag is just fun to play with. Okay, so when there's good old rules with a bipolar transistor, when there's a base emitter current, there will be a collector emitter current. So what I'm doing here is I'm taking this and just jump over these, put a pull down resistor on it, and right here, this is my signal. And what happens, so this is I just got a 1K on here right there. So now, being this is a very sensitive transistor, about 10 milliamps, if I dial it up here, that's 20 per division. So we got maybe 10, maybe a little less milliamps of idle current that the servo pulls for its logic. That'll activate this transistor normally, so we don't want that. So what we do here is I've just had to pull a 47 out of the bin because I couldn't find 10 ohms, but whatever. The value of this isn't, it isn't critical. There's a wide variety of values that'll work just great for it. So basically, until this is, I could put servo, look, I could label this and everything. Okay, that's a servo. When the servo draws current to run the motor, this transistor will turn on, and this signal will go high. Now, this can be done the other way around. Just for those who say, hey, but you shouldn't do it like that. But there'll be people who say you can't do it the other way either, so whatever. Okay, this is just turning around my transistor. I shall show you. And some people will like this better, but it doesn't matter. Oh yeah, the lag is so much fun to play with. Okay, this is an Npn transistor now. And what I'll do is, for those of you who want to drive their servos with a different voltage, I'll do that. And then this is 1K. And there's different advantages to these different circuits, but whatever. Figure it out. 47 ohms. Oh yeah, this is very interesting with the lag. I'm having great fun here. Okay, this is my servo pulse controller generator thingamabobber or whatever. This could be our RC receiver or whatever. I don't care. It's generating control pulses for the servo. Now, this circuit would do the same thing, and it uses an NPN transistor. So basically what's going to happen is it's negative and positive rails. And this positive could be 5 volts, it could be 6 volts, whatever you want, I don't care. The reason I've said this is 5 volts and not just attached up here, if you want to use your Arduino or whatever, then this will be your 5 volt logic level, and this can be your motor power or whatever. Oh, I love the lag! Oh, it's great! Okay, but you will get an inverse pulse here. So this will normally be high, and then when the motor pulls a pulse, you'll get a low out of it. The reason I did this down here was because this will normally be low, and when the motor pulls a pulse, you get a high. And I think this is a lot more clear on the scope for the people who are trying to understand what's going on, other than seeing it high and going low. No, I don't care. Anyways, absolutely, completely unmodified servo. Really, I didn't modify it. And that is how you can do load detection for a hobby servo without modifying the servo. The one thing this doesn't let you do is cook eggs. No, wait, that's not right. The one thing this doesn't let you do is know which direction the feedback or the load is. So if I push this way, you will see I get my pulse going bigger, and if I push the other way, I'm going to make it clear that I'm pushing it the other way. Really, I'm pushing it the other way. Then you see the pulse gets bigger in that direction. Now, with a little bit of software, a system could say, well, wiggle me a little and figure out if this gets away from the load or if that gets away from the load. And by knowing when you turn which direction the load gets lower in, then you can work out which way the force is acting on the servo. Because everyone knows that if your electronics are no good, you just dump it on the software guy to fix everything, because they can supposedly always do that. Anyways, there you go. Load detection on a hobby servo. It's very sensitive. This is, I'm noticing I've got this scope set to 1 millisecond per division. See, check it out, it really is. And my pulse generator does 10 milliseconds per pulse on the servo. If I just give the servo just a tiny hair of pressure, then I get about half a millisecond. And if I just about strip the gears on the servo, I can get it up to 9.5 milliseconds. So there's between 0 and full load on the servo, there's a really big difference in the pulse length. And if I dial this up a bit, and you can see that if I even show you what I'm up to, and it's just, I'm trying, I really am, it's just the wires are too short. It's really sensitive on the pulses, and there is a bit of an initial jump there, but after that it seems to be pretty linear with where it goes. So that is force feedback. Oh, and that's my messy bench. Yes, right there. You see, never get around to cleaning it up. I don't. So, have a good breakfast or whatever, supper. I don't know when people actually watch these YouTube videos and stuff, but good night, all.